Hello everyone. Today in this part 4th of continuity and differentiability, I let you know about the differentiability and differentiability of a function about a point. Before this, in last video, I had explained about the continuity about a point and the continuity in an interval. Now, first of all, we have to understand what is the meaning of differentiability. Roughly speaking, if we will say there is a function, let us suppose we have f d to rb a function where d is the subset of rb an interval and let y is equals to fx. Now, if we draw the graph of this function by a graph in Cartesian plane and its graph has no corner points and has unique tangent with finite slope at every point of the curve, then we say that f is differentiable. So अगर एक फंक्शन को डिफरेंशिएबल प्रूव करना है अबाउट अ पॉइंट, then graphically if we will check, then there should not be a corner point and has unique tangent with the finite slope at that point of the curve. And if we have to prove the differentiable at every point, then at every point there should be no corner points and there should be a unique tangent with finite slope. How will you come to know? Look at this thing. I had given two pictures. Now in this first figure, what are you observing? At O we have the corner point. That is why at O we will not say that the function is differentiable. In B part, what are you observing? At O point, we have the vertical line. It means the tangent is there, but the slope is not finite. Because this becomes 1090. 1090 means not defined. So even then we have the finite slope, but we have that slope, but it is not finite. Hence we can say this function is also not differentiable at O. तो किसी भी फंक्शन को डिफरेंशिएबल प्रूफ करने के लिए अगर हम ग्राफिकली उसका चेक करें तो ये दो पॉइंट्स हमें जरूर चेक करने हैं कि एट दैट पॉइंट देयर शुड नॉट बी अ कॉर्नर पॉइंट्स और अगर वहां स्लोप मिल रहा है देन स्लोप शुड बी फाइनाइट. सो this is the idea of the differentiability. Once again I revise this thing. Case of continuity, graphically what we were observing, if we will draw the graph of the function without lifting the pen or pencil from the surface of the paper, then we can say that the function is continuous at every point. But in case of differentiability, at that point there should not be a corner point and has unique tangent with the finite slope. Now mathematically how will we do? For case of mathematically, we will take x is equals to c be any point, and if both the limits, this is the left hand derivative, limit h tends to 0 fc minus h minus fc upon minus h, and limit h tends to 0 fc plus h minus fc upon h exist finitely and are equal. So slightly formula is changed. It is known as the left hand derivative and it is known as the right hand derivative. So let's start with one question. Look at this thing. We have to prove that the function fx is equals to x square is differentiable at x is equals to 1 and hence find f dash 1. So first of all we will find out the right hand derivative. Now for right hand derivative we will write down limit h tends to 0 f c plus h. What is the c here? For here c is 1. f1 plus h minus f1 upon h. So substitute the values here. Limit h tends to 0. But this become f1 plus h means 1 plus h whole square. And substitute f1. This become 1 and h is as it is. Now look at this thing. Limit h tends to 0. This is 1 plus h square plus 2h minus 1 upon h. Now 1 cancel out. This become limit h tends to 0. And what is this thing? What is the common here? H. What is this thing? 1 plus 2 h plus 2 upon h. So what is this thing? 2. Now left hand derivative. Left hand derivative means limit h tends to 0, and what this become? f1 minus h minus f1 and upon minus h, and this is equals to limit h tends to 0. What is this? 1 minus h whole square minus 1 upon minus h. Now open this identity. Limit h tends to 0. 1 plus h square minus 2h minus 1 upon minus h. Now what is the common? Limit h tends to 0. Common part is h. 1 cancel out. What this become? 1 minus 2h. 1h minus 2 upon minus h. Now substitute the values. What will come? 2 only. Now you will say, because right hand derivative is equals to left hand derivative at 1, which is equals to 2. Therefore function is differentiable and the value of f dash 1 is equals to 2, and also function is differentiable. So this is the way when we have to prove that function is differentiable by mathematical steps. Now this is the one question. You have to give the answer of this question in the comment box. Related to this question, I had already explained in continuity, but in case of differentiability, we have to change this formulas. Thanks and God bless you. Don't forget to subscribe, like and share this channel.